Hello all, my name is Yash Sathe. The topic of our presentation is development of carbon electrodes from various materials for designing supercapacitor. The group members in this project is Venkatesh Singare, Kaustubh Gaikwad. Also, we have developed this project under the guidance of Professor Gayatri Palatnikar ma'am. Index. The topics we are going to see in this project is project title, project's aim and objective, its literature survey, its review, its flow diagram. In flow diagram, we will be focusing on selection of biomass materials, identifying the properties of biomass materials, its implementation of activated carbon, development of the activated carbon, uh, supercapacitor electrode assembly, its testing by both its hardware and software. After that, we'll be going to conclusion, its project planner and references. The main motto and aim of our project is to make supercapacitor using agricultural biowaste with different shapes. The objective of our presentation is to finding an alternative material which will be economically efficient with better charge properties. Also, it will be beneficial for farmers to compare various effective output responses from different type of biomass materials and to know which biomass material is the best for better charge properties. Why supercapacitor? As we all know, the difference between battery and supercapacitor, the battery is having very high power density, rapid charging, high cycle life, high efficiency, wide temperature range, and high it because of high temperature range, it gives us high safety. Uh, Comparing between lead acid battery and supercapacitor gives us high charging, very quick charging time and very quick discharge time. It has also high life cycles, specific power, and operating temperature. Uh, Focusing on taxonomy of supercapacitor, we are focusing on the electric double layer supercapacitors, which are electrostatic charged supercapacitor. Uh, in this electric double layer capacitors, we are focusing on activated carbon, uh, as it is easy to get the activated carbon from biomass materials, and biomass materials are easily available in the surroundings.
literature literature survey and review of project. For a study of this project, we have studied the different research paper. The first research paper is development of three electrode system for optimizing the parameter of hybrid capacitors. And the key points from this paper is electrical energy storage, electrodes, electrolyte, and hybrid capacitors. Second is material for electrochemical capacitors. And key points are nanostructure material, carbon nanotubes. Third is the tamarind seed carbon preparation and methane uptake. And key points are tamarind seed activated carbon and chemical activation. Fourth paper is research development of a supercapacitor electrode based on carbon material. And the key points are carbon material and electrodes. Next. Fifth paper is carbon-based electrode material for supercapacitors, its progress, challenges, and prospective solution. And the key points are storage mechanism, electrochemical double layer capacitors. And the last paper is effect of electrodes shape on parameter of supercapacitors. And the key points are electrochemical double layer capacitors and ultra capacitors. These all research paper are very helpful in the study of this project, and also the important for the process of project.
The first process to make the development of supercapacitor, we can extract the various biomass materials such as sugars, bagaces, tamarind seed, coconut husk, coconut shells. These biomass materials under the process of pyrolysis process. The supply of nitrogen cylinder is given to the furnace. The furnace is set the temperature of 500 degrees Celsius. In this process, we can extract the activated carbon, and this activated carbon, with the help of activated carbon, we can make the supercapacitors. Next slide. This is the process of extraction of supercapacitor with the help of furnace. In this furnace, we can set the temperature of 500 degrees Celsius and pressure is 15 psi. From this process, we can extract the activated carbon from the biomass materials such as rice husk, coconut shells, coconut powder, coconut husk, etc. These are the recent developments in the development of supercapacitor. The biomass materials which are selected as a neem leaves, banana leaves, ashoka leaves, rose petalets, pista shells, date seeds, and jackfruit seeds. These are the specific capacitance from the each and every biomass materials and equivalent register for these materials. We have selected the biomass materials as tamarind seed, sugar bagasse, coconut husk, coconut shells, and from these we have selected the different properties: density, thermal conductivity of the material, specific heat capacity, heat transfer, thermal expansion of coefficient, pore size, ash content, moisture content, and surface area. For making and the shapes of construction and detail the supercapacitor, we can select the mesh sheet carbon collecting electrodes, and polythene sheet is used for the separators. Next, ladies. We can check the various electrode shapes such as triangle, circle, straight strips, rectangular, square, ellipse, and semicircles. These are the dimension with the basis of the electrodes we can make. The development of anode and cathode. The anode is the slurry carbon pasted of anode is a mixture of carbon plus MnO2. On cathode, the only activated carbon is pasted. From these from this all the process we know that the three separators are used for making the supercapacitors, and two electrodes are combined to form the supercapacitors.
The main part of this project is experimental setup and testing of the material. Now we see the testing procedure of the this supercapacitor. First, we use the DC supply to charge the supercapacitors, and ammeter is connected in the series of the circuit. And then the voltmeter is connected in the parallel of supercapacitor. Then ammeter is measure the current discharge through the supercapacitor, and voltmeter is for the measurement of voltage between two terminal of the supercapacitors. Now the testing of testing procedure. First, we give the 2.2 DC volt supply for 3 minutes, discharge charge the supercapacitor, and after 3 minutes, we switch off the main supply and discharge the supercapacitor using the internal resistance of the ammeter. Follow this after the after this follow the same charging discharging procedure for the 3 times, and after that we charge the supercapacitor for 1 minute for 5 times and take the reading of discharging current and discharging voltage with respect to time, and all from this reading we calculate the specific capacitance of the supercapacitor.
By testing the supercapacitor electrodes of rice husk, coconut shell, coconut husk, groundnut shell, tamarind seed, and sugarcane bagasse, we have found out the specific capacitance of the supercapacitor respectively. We are getting the rice husk 1.8 farad per ohm is the most effective specific capacitance of the supercapacitor. Also, we have studied and tested the supercapacitor materials in the software that is called COMSOL multiphysics. As in COMSOL multiphysics, the different materials we have taken into consideration, like rice husk, coconut shell, coconut groundnuts, are not available for testing. So we have, on the basis of their properties, on the basis of their properties, like density, thermal permittivity, thermal conductivity, water content, porosity, we have developed a supercapacitor, and we have tested it in COMSOL multiphysics. We are getting the specific capacitance and Maxwell capacitance. Also, we are getting its charging and discharging graph. So we can consider its capacitance. By this project, we are come to an conclusion that supercapacitors are energy storage devices that can store and deliver large amount of energy quickly on promising area of research in the use of biomass materials for supercapacitor electrodes, as they are renewable, abundant, and have potential for low cost production. Thank you.